So I'm here really to issue a dire warning about some very, very bad ideas about causal efficacy, really about the idea that causes producer effects involving the exertion of influence of something on something else, which is a part of the kind of causal realist tradition and an aspect of it that we can discuss without getting entangled into questions about necessity. I will leave it to you to decide to what extent these ideas are prevalent in contemporary approaches to causal production. I think I can see them present in all of these accounts to varying degrees and in different ways. But I'll go straight for the ideas. And the first warning goes out to the idea that causation can and should be accounted for in using the so-called event causal model. And this is a view that I feel, or I suspect that a lot of people think is the way philosophy has been thinking about causation really since forever, i.e. that causation is a two-place relation between two distinct entities, such as the first exerts an influence on the second. But I venture to say that this is very much a 20th century idea, and the earliest explicit statement to this effect is one I find in Russell, in his paper on the notion of cause. And I think we should take a look at that paper to see that he's making a mistake. He's complaining about the notion of cause, famously, and complaining in particular that it's difficult to even find a clear statement of the law of causality, i.e. that causes necessarily produce their effects. And that's in a way not surprising, since he doesn't go look for it in the bygone age that he's worried about. He only wants to look at the contemporary approaches. And there he doesn't find much, because he's writing in an era where reductive empiricism is all the rage. Had he gone back to the bygone age, he would have found statements in Aristotle, in Buridan, Suarez, Malebranche, Hobbes, Galileo Galilei, and basically anyone writing in any of the main realist traditions. But that's not what Russell does. He aims to find out what philosophers in general think about the notion of cause, as if everyone were a causal realist in the early 20th century. And he does this by looking it up in Baldwin's dictionary, the entry on cause and effect written by G.E. Moore in 1901. And there he finds the following statement that he is satisfied with, which is that cause and effect are correlative terms denoting any two distinguishable things which are so related that whenever the first ceases to exist, the second comes into existence immediately after, and whenever the second comes into existence, the first has ceased to exist immediately before. Now, my complaint here is that this has absolutely nothing to do with causal realism. This is really just reductive empiricism, the constant conjunction formula. Really causation reduced to a very abstract successor relation between anything and anything, right? Nothing is said about whatever exerts an influence or on anything. But Russell thinks that this is causal realism, and that comes out later when he says that it would seem that only the later parts of the effect of a cause can be relevant to the effect, since the earlier parts are not contiguous to the effect and therefore by the definition cannot influence the effect. Now, the problem is that he hasn't actually offered any definition that says anything about why influence is there at all and why contiguity is important for it. So we have to guess a little bit about what's going on in the back of Russell's mind. And let us first note that it can't be Hume's contiguity, because that has nothing to do with causal efficacy. Right? Hume doesn't believe that we have any impression of anything being transmitted to anything else. For him, contiguity is just something, really the appearance of contiguity is something that triggers a principle of association in the mind, making us believe that the objects are related, which is an irrational thought on his behalf. Right? The only thing that I can think of that's relevant for causal realism is the principle of locality that says that influence can only be exerted on contact, right, or through intermediaries. Right? And now we have very explicitly the claim that causation is first this, then that, and it first exerts an influence on the second. And this is a way of thinking about causation that I think is reflected in later thinkers very clearly. These are examples from the literature in recent times. I won't go into detail here, but note that, for instance, Bigelow, Ellis, and Pargetter argued that causes exert forces on their effects. Now, Russell is quick to point out the problem with this view, which is that if time has the structure of the continuum, then between the end point of a cause and the beginning point of an effect, no matter how close they are, there's always going to be an infinity of time points in between, at which, in theory, something could happen to prevent the cause from exerting its influence on the effect. And this is what we now know as the problem of actions at temporal distance. And yes, we can marvel at the ingenuity of the argument as it's structured or constructed, but we should worry if anyone has ever argued for this view before that Russell is now demolishing. And I venture to say that nobody has. Now, of course, I could be wrong. Maybe someone has argued for it in the past, but they would just be equally wrong in light of what I argue later. But it's also clear that Russell isn't basing his view on anyone else. He's making this up for himself. Now, to figure out what philosophers actually did argue about causal efficacy before Russell, then we really have to go a fair few years back in time, really to the bygone age before Hume, really, and to find any explicit statements. And there we find actually a remarkable agreement among all the realist traditions, really all the way back to Aristotle. And we can paraphrase the agreement in form of what I call here the powerful particulars view. And of course, I mean, there were differences, obviously. I mean, not everyone agreed that the continuums involved were hylomorphic substances. Some believed them just to be extended solids. They didn't agree on final causation. There were some quibbles about essences, but the essences were rarely part of their causal account anyway. What they did agree on was that causation is when some object with an active power, an ability to exert an influence on other objects, came into contact with an object that had had the passive ability to receive the influence, the active influence, and changing accordingly. So they would agree to the following description, roughly, that when a brick comes flying through the air with momentum, kinetic energy, velocity, and comes into contact with a passive recipient, here a window sitting in its frame doing nothing but be fragile, then on contact, certain things begin to happen. The brick begins to exert an influence, takes a little bit of time to exert it, and at the same time as the influence begins, a change begins in the window, and that change takes time as well. So under a certain period, temporal period, you have an influence and a change happening simultaneously, but not instantaneously, giving us really a continuous succession of states, end result being a brick lying at rest in a pile of broken glass. And this is a conception of simultaneous causation that it seems to me was regarded as basically given in the 18th century. You have Kant talking about it, not pointing out any paradoxes or incompatibilities, but just to worry, how can we still think of the effect as following the cause? And he says, well, it's when the cause ceases to be, the effect remains. Now, there are two aspects important to point out in contrast to the event causal model. And the first is that influence isn't from cause to effect. The influence is between the continuants involved in this, what we could now call the cause event. Okay, it's the brick that acts on the window. The brick doesn't act on the breaking, right? And then what we call then the causal relation between first this, then that. That's here represented not as constitutive of causation, but a consequence of it. Right? It's the outcome of an interaction between powerful particulars, and that's quite a big shift in our perspective that we have today with the event causal model. Now, best mention that this conception of simultaneous causation is today regarded by many to be paradoxical. How could they be simultaneous? And that's because people begin with the event causal model, first this, then that, and then someone says, oh, but they're simultaneous. Then you see everything collapsing to a point and a situation where the window is whole and broken at the same time. But that isn't a consequence of this powerful particulars view, but only of the assuming first event causal model and then insisting that they're simultaneous. Now, the point here is, of course, not just to argue that, what the olden philosophers thought. but actually to argue that they were right. And it seems to me that the event causal model just cannot be used to combine an account of influence and production all in one go. It is too, in a way, simple to do that. And the reason why comes out nicely, I think, if we take a look at what Hobbes has to say about causal interactions. So he says a body is said to work upon or act, that is to say, do something to another body when it either generates or destroys some accident in it. So it's the bodies, the continuums that act on each other. That accident which is generated in the patient is called the effect. And this really entails that it's impossible for the action of the agent or the active object to act on the effect, because the effect doesn't exist to be acted upon until after the first body has acted on the second body to provoke a change in that second body to give rise to the effect. The effect is also an outcome of an interaction between the continuums. And he continues to say, when an agent and patient are contiguous to one another, their action and passion are then said to be immediate, otherwise mediate. And this, the interesting thing here is that he's not worried at all about temporal contiguity. That's given, right? The only problem is, are they spatially connected to continuance? And that's because the object that acts and the object that's acted upon are never out of time with one another. They are temporally contiguous before, during, and after the interaction. They are never, out of time. And arguably, that's the only problem that we've ever had with action at a distance. Russell's depiction of the event causal model creates this fake problem of action at a temporal distance, a problem that nobody's ever had a problem with before. Newton's problem was with heavenly bodies gravitationally interacting with each other at a distance. It was given that they're temporally contiguous. The action is simultaneous or instantaneous. And that's written into the mathematics of the theory. The only problem was they're spatially separated. And today we have the problem of entangled particles, two particles behaving simultaneously in correlated ways, or at least too closely enough in time to allow information or influence to pass between them. So again, it's the spatial separation, not the temporal separation. If there had been a temporal separation, we could have assumed something, passes between them. So action at the temporal distance is a fake problem arising out of the assumption that causal influence is from cause to effect. Now, and in fact, the more I think of it, the more the event causal model appears to me like an anomaly in human intellectual history, right? It's just nowhere to be found except in a period in the 20th century and only confined to philosophy. You won't find it in the Aristotelian or the atomistic or the scholastic tradition or even in the mechanistic philosophers of that period, and the natural philosophers of the early Enlightenment only ever talk about bodies or atoms or substances or whatever continuance that they postulated to be real. One could wonder, is there any kind of basis for the event causal model in common sense? And I would say it's ambivalent, really. When we act in the world, we know we have to act on the object. I have to kick the ball to make it fly across the pitch to score a goal. I don't kick the scoring of the goal, right? But when we talk about causation in our everyday lives, we talk about, the kicks caused the goal or something like that, right? Or my hitting the baseball with a bat caused the breaking of a window somewhere, right? And then we're actually connecting distal causes and events, right? Events that are causally or spatio-temporally separated as cause and effect. Now, common sense is always difficult to deal with. What about science? And it seems to me that whenever science can even be interpreted as saying anything about causal efficacy or influence, it's between the continuants. All the fundamental forces operate between the continuants of the standard model. In fact, whenever there's a behavior that needs to be explained by appeal to a force, a particle is postulated to carry the force, right? A continuant, right? And what they do in the Hadron Collider, they accelerate particles to smash them into each other to see what happens. In chemistry, you have chemical compounds reacting with each other. Oxygen reacts with some fuel to combust. Oxygen doesn't react with combustion. Doesn't matter the scale, the parts of a bicycle or a suspension bridge, they act on each other in a way that we now describe as stress, and galaxies interact. You know. So it seems to me that this event causal model arises out of a mistake, and it should be abandoned. Now, moving on now to the second problem, or second bad idea, which is the idea that influence is unidirectional, either from process to process, from entity to entity, from one event to another event, or from power to manifestation. It doesn't matter what entities you're postulating. Now, admittedly, this is an idea that makes very good intuitive sense to us, especially perhaps in light of the kind of examples that we typically look at, which normally involve an object in motion acting on an object at rest. Like here in the Newtonian cradle, we can almost trace the influence being passed along the row of balls. And of course, we might have been looking at these examples because for a very long time, really ever since Aristotle talked about active and passive powers, we have assumed that that's what causation is about, the exertion of influence of active on passive entities. But this idea is very difficult to square with the very adamant rejection of unidirectional influence by the natural sciences today. They basically categorically deny that any unidirectional action exists. Instead, they insist that influence always comes in the form of reciprocal interaction of the kind stated in the third law of motion. And I think we can see this kind of influence as soon as we look at symmetrical rather than asymmetrical interactions. It's even clearer when we don't have a ball in the middle at rest. You have 4 balls and you lift 2 balls on either side and they go like this, right? Because as it is now, it's possible for you to conceptually think of the ball in the middle as first compressing before it bounces back to hit the other balls, which is a misdescription of the mechanics involved here, right? So according to this idea, the third law, which, by the way, yes, it's a part of classical science, which is supposed to be an outmoded framework, but this is one of the components that still is assumed to hold good, right? It carries over into the quantum mechanics. And we're supposed to be able to generalize it, saying that whenever any object whatsoever acts in any way whatsoever on any other object whatsoever, the second always acts on the first in the same way, to the same magnitude, and at the same time, to a degree that it's completely arbitrary which is the first and the second object. And this is just taught in physics 101 as a given way of understanding interactions. The symmetry in the asymmetric interactions that we see in this here, we're supposed to understand that there is still a symmetry because we have to bring in now the concept of work, which is fundamental for our understanding of energy. Energy is what can do a certain kind of work. And the idea here is that it takes an equal amount of work to stop a ball as it takes to move a ball, right? So the influence has to go both ways. Now that's all I have really to say about the dangers of unidirectional influence. I've been warning against this concept since I published my paper, Causal Production as Interaction, in 2002. And very recently, I published this book, A Powerful Particulars View of Causation, outlining a conception of causation that takes a reciprocity of interaction seriously. But having introduced reciprocity, I need to warn you about a bad way of understanding reciprocity. Or let's call it just a disambiguation of the term, because there are at least 3 ideas about reciprocity currently in the literature. The first is similar to or relates to the first 2 ideas that I've been talking about, and it's sometimes formulated as the principle of reciprocity, sometimes as the principle of proportionality. Says approximately that the cause must lose as much as the effect gains. Some kind of reciprocity going on between cause and effect. This is a pre-Newtonian concept, and on the basis of this, it has been argued that the idea of simultaneous causation becomes problematic. And you can illustrate that perhaps best with appeal to or using the transmission account of causation. Let's say we have a billiard ball with a certain momentum. It's in motion. It hits a ball at rest, and somehow the momentum here is supposed to be transferred from one to the other, right? Some quantity of motion, right? And then the ball must lose as much as the other effect gains, right? But if cause and effect are simultaneous, it would seem that this ball both has and hasn't got the momentum, and this ball hasn't and has got the momentum, which means that both balls have the momentum at some point, which means a doubling amount of the quantity of momentum. But that's, again, a consequence that follows from accepting the event causal model, first this and that, and then claiming that it's simultaneous. And that problem disappears if you think of causation in terms of reciprocal action between continuants, yeah, the powerful efficacy. And one can just argue that there's a mistake here about based on this this event causal model, really, but also it might not have to do too much about causation at all. This is just a condition, really, that's a boundary condition for any material system. Basically, it has to do with conservation, that you can only get as much out of a system as put in, and you have to get exactly as much as put in, right? Everything else would be violation of conservation. But it doesn't really tell us anything about what happens within the system to bring us from input to output, right? It just says whatever happens, it has to be conserved. Yeah. So it's not a very clear relation here to causation at all. Now, then there's a talk of reciprocity in power-based accounts of causation, and that's more to do with the kind of affinity that certain active powers are supposed to have with certain passive powers, that they, in a way, join up to equally contribute to an outcome, but then the outcome is typically what happens to the passive object. So the ability to break that is supposed to be in the brick, and the ability to be broken in the window, they join up to cause the breaking of the window. And what happens to the brick is kind of left out of account. I would say that that's in a way just fixing on the a certain kind of event causal model and on unidirectionality of influence. And if those concepts are wrong, there is something wrong with this idea that this is really a question of reciprocity here, right? Rather than just the question of fit or something like that. And finally, you have the idea that reciprocity has to do with the mutual influence that two continuants act on each other, and how they both change as a result of this. Which, by the way, we should add at the end, doesn't remove the asymmetries that we typically perceive. We just have to add the idea that the same kind of influence can have very different effects on different objects because they are different to begin with, right? So if a brick hits a window that is fragile, it will break. And if it hits a bulletproof window in exactly the same way, the bulletproof window won't break. But are we then supposed to understand it, as an empiricist would say, you have to understand everything in terms of the observable consequences? Then when a brick hits a fragile window, it's exerting the breaking power. And when it hits the bulletproof window, it's exerting the bouncing power, perhaps, because it bounces back from the window. Rather than saying it exerts the same influence on both objects, but because they're different, they react differently to it, and we get different types of outcomes. That means that we get asymmetrical interactions, even though there's a symmetry in the influence being exerted between them, right? The bulletproof window exerts a force on the window just as much as the brick exerts a force on the window. Now, and this conception of reciprocal interaction between continuants is compatible with the idea of simultaneous causation. That's as much as I have time to talk about today. And thank you for listening, and hope you have plenty of ideas. Thank you. Of questions, rather. Sorry.